NEET 2025 didn't go as planned.
535 marks.
बस थोड़े से मार्क्स से रह गई। बायोलॉजी ठीक था, केमिस्ट्री भी, पर फिजिक्स वो फिसल गया। इस बार पढ़ाई नहीं, तैयारी करो, वो भी स्मार्ट तरीके से, क्योंकि इन्फिनिटी लर्न लाए हैं अट्रेया, इंडियाज मोस्ट पावरफुल नीट रिपीटर्स प्रोग्राम विद P² CB, जिससे फिजिक्स पे होगा डबल फोकस।
Don't just make it your last try, make it your best one yet. Join Infinity Learn today.
Hello, good noon my dear students. How are you all? Welcome to one more amazing session from Infinity Lane. This is Suresh, Faculty of Chemistry. How are you all doing? How are you all doing? आज हम चर्चा करने वाले हैं Bohr's atomic model. This particular topic is going to be double benefit for you in chemistry as well as in physics. How are you all doing? Please confirm. Can you all able to hear me and see me? Dear children, here about Bohr's model, you are going to expect at least one question from every year from the structure of atom. So, hi Anisha, good afternoon. In the previous class, you are not here. So, attend my class on a regular basis. You will enjoy the pace and we are going to do some good questions and discussion of the entire topic is going to be there in a detailed version of today's class. Okay, before going for this structure of atom, Bohr's atomic model, you are not well. How are you now? Doing good, Anisha? Right, going forward, we are all preparing for NEET examination. This is a Nirman program where we are targeting NEET 2026, and this class is completely on YouTube on live sessions, and you just join and write by taking a pen and paper, make a noteworthy points. We are going to give in between some tricks and tips as well to solve a critical questions as well. Yeah, now what I want to say, these sessions are completely free. We don't expect anything from you, and Infinity Learn from YouTube channel, we are doing the best to produce the best of the best results. And in 2024, even 2025, the students actually attended all the classes with us, got a very good score. Some students got 650 plus, some students got 700 plus, also expecting to do so. And you will be the same for the next 2026 Nirman program. Before going for that, I just want to introduce a small promotional slide for you. It is the Atreya program. Here, let us change. It is the Nirman program where Atreya program is given by Infinity Lane by Chaitanya Academy. And we are going to take a change from your status. So, आप 2025 में इतना अच्छा नहीं किया, कोई प्रॉब्लम नहीं. We want to change your status from I didn't do to I will do it. That confidence we are going to give by this P² CB program. This is Atreya program where India's most powerful NEET repeaters program where P² CB. What is this P²? Physics twice a day, chemistry and biology. So, when you prepare for your NEET examination, biology ठीक ठाक, chemistry भी ठीक ठाक, लेकिन physics में थोड़ा सा दिक्कत है. It is going to be a nightmare. For that, we want to take a resolution, physics honors. We want to double the preparation for your physics. That is the P² CB program, where double focus on physics with chemistry and biology. Enroll now in the pinned messages. The link is there and the description box link is there. You all click it and get the details. Let me explain you in brief what is a program here. Program structure, and it is started May 23. Already started. You can enroll still, but remedial classes will be conducted. And the classes are from Monday to Saturday and Sunday ko chutti hai. And you will be having each class, har din ka 3 classes ke. And in that 2 concept classes, 1 practice session. In that you see 3 classes per day, each class is 90 minutes and it is 1 hour 30 minutes and 18 classes per week, and in that we include physics double preparation. So this is a golden chance for you all preparing for your NEET droppers, and you can just enroll it and you can pursue. And you can see interactive classes by expert faculty, 465 classes and 240 daily practice papers will be given, and dedicated practice session 120 plus hours practice sessions will be given, and after class revision notes will be automatically uploaded in the portal to you, and you can just go through that PDF formats. And batch size खास बात है 20 to 25 students only. We are not going to dump hundreds of students in a single batch in the practice session. So you will be having 20 to 25 students maximum, so that you will be having a very good rapport and interaction with your faculties. So you can have customized doubt clarification with the less number count over there, and you will be covered total 11th and 12th syllabus, my dear children. And also you can see, once you did your NEET 2025, let us check your strategy and how you are going to get expected rank and expected colleges and college predictors. So that is also feasible. The link is there in the description box. Just look into that and you click it and you just follow up. And please like this session and share with your friends and subscribe to Infinity Learn NEET YouTube channel. And we are here to help you for your dream medical college journey. Okay, so promotion is over. Let us start with Bohr's atomic theory. So what Bohr's atomic theory, Anisha, Bohr's atomic theory is the theory which is actually we still follow it. And you may say that Bohr's atomic theory is failed. Hi Geeta Madhuri, hi, how are you? Okay, so let us say Bohr's atomic theory is true and we follow. And Bohr's atomic theory failed to explain certain parameters like Heisenberg uncertainty principle. So dual nature can help us to take the Bohr's atomic, still it is true and everybody is following that. So what is the back end behind this Bohr's atomic theory? So I'll tell you a story. And Bohr was actually deputy to Rutherford, and Rutherford given the atomic structure that is actually redesigned and re-explained by Niels Bohr by taking the hydrogen spectrum as an evidence. If you look into the Rutherford model, Rutherford failed to explain the hydrogen spectrum or atomic spectrum. I am fine, thank you Geeta Madhuri. And he was nervous. Long ago I have seen you and you are doing the best. So take care of yourself and attend our class, take a pen and paper and write. And we study Bohr's atomic theory as it is, but you need to know the reason behind the Bohr's atomic theory. Bohr's atomic theory is a modified version of the Rutherford theory. Actually Bohr was a deputy to Rutherford in the same laboratory. Hi Varsha, good afternoon. So Rutherford failed to explain hydrogen spectrum. Spectrum is not explained. And Rutherford failed to explain the stability of atom. And by taking these two drawbacks, and Bohr corrected his theory by taking the hydrogen spectral experimental data and Einstein photoelectric effect, Max Planck quantum theory. And he reinforced and rearranged the theory. And to understand the Bohr's atomic theory, let us carefully look into some aspects as far as the hydrogen spectrum is concerned. Ready? So what is a spectrum here? You see, this is a beautiful animation designed by our content team. When a light is allowed to fall on the prism, the wavelengths present in this light is going to be reformed into its constant wavelengths. That is require a spectroscope or spectrogram, and spectrogram or simply spectrum of the given radiation of spectroscopy. Sir, you are talking about atomic structure, why unnecessary light is coming here? That is the biggest question. Yes, we need light because atom is such a small entity. You can't go inside the atom, I can see. Somebody asks you, can you see the atom? By using a sophisticated equipment. I simply say no. You can't see the atom, but you can see the image of the atom. That is nothing but your spectrum. Yes, and this is the spectrum of a normal white light. When a light passes through a prism, it resolves into its constituent wavelengths. Right. Can we smell atom? This is matter. Matter is made up of molecules. Molecules has atoms. If you smell, smelling is a bulk property. So you are going to smell the substance, not the atom. So the substance itself has an atom. Yes or no, Geeta Madhuri? You love that answer? Okay. So let's talk about the various. This is what is called as a spectrum. What you can see? Violet, indigo, blue, green, yellow, orange, red. You know? So this image is taken and that is called a spectrum. WaveGR. So let's talk about the various types of spectrum here. Classification based on the nature of the spectrum. Spectrum is two types, discrete and continuous. And continuous means the wavelengths are continuous. There is no gap between the wavelength to wavelength is called a continuous spectrum. While discrete means discontinuous spectrum. This discontinuous spectrum means there should be some gap between the wavelength to wavelength, that is called discontinuous spectrum. And this discontinuous spectrum is called as line and band, two categories. So atoms are going to produce a sharp distinct lines is called as a line spectrum, that is also called as atomic spectrum. Atoms produces line spectrum, right? And the bunch of lines appears like a band, and that is produced by molecules, that is called molecular spectrum. So that is called band spectrum. Hi, Phantom. In my childhood days, Phantom is my favorite. हिंदी भी हो सकता है ना. अगर आप वेवलेंथ कंटिन्यूस रहे तो बीच में कुछ गैप नहीं होगा, इट्स कॉल्ड कंटिन्यूस स्पेक्ट्रम. ये डिसकंटिन्यूस स्पेक्ट्रम क्या है? दैट इज कॉल्ड डिस्क्रीट स्पेक्ट्रम. वेवलेंथ बीच में थोड़ा सा गैप मिलेगा, दैट इज व्हाट इज कॉल्ड एज line spectrum, that is shown here. This spectrum, line spectrum, is of two types. One is absorption spectrum or is an emission spectrum. Absorption spectrum is formed by absorption of radiation, okay, and emission spectrum is formed by emission of radiation. How it is formed? Whenever the atom, the electron jumps from low energy to high energy, so this is going to absorb some radiation. So जब इलेक्ट्रॉन लोअर शेल से हायर शेल तक जंप करने के वक्त में ये एनर्जी एब्जॉर्ब हुआ, and this absorption of the wavelength gives a spectrum is called absorption spectrum. And emission spectrum, this emission spectrum, whenever electron jumping from higher shell to lower shell and it is going to emit the radiation, that is called de-excitation, and this de-excitation process loses energy or emits energy, and this is the excitation process, absorbs the energy, and absorption spectrum यहाँ पर मिलेगा and emission spectrum you are going to get. So, infinity learn 9th to 10th. Okay, Geeta Madhuri, Phantom, as per your question, doubt the answer. Phantom, he is a NEET aspirant who is preparing for NEET UG exam 2026. Okay, nice joke. Talking about emission spectrum, absorption spectrum. So, let us talk about this continuous spectrum. This is your continuous spectrum. Okay, so what do you observe in this continuous spectrum? बच्चों देखो, you are going to have the violet wavelength here. Okay, you are going to see the violet wavelength here, indigo, blue, green, yellow, orange, red. Can you see any gap between yellow to orange? No. Yes, Sri Chaitanya didn't got AIR this year. Yeah, no. We got AIR 1. Okay, orange to red, there is no gap. So the wavelength is continuously, we can see blue to green, there is no gap. So the continuous array of wavelengths is called as continuous spectrum. Okay, so let us talk about discontinuous spectrum. This is also called as discrete spectrum. When you observe this is a wavelength, this is a wavelength, there is a clear cut gap between the wavelength to wavelength. You can observe a gap between wavelength बीच में कुछ gap मिलेगा ना. So this is not continuous, this is discontinuous spectrum. And in the discontinuous spectrum, wavelength is wavelength separated by a, yeah, I am a doctor. Okay, let us make a chit chat as well as learning process should be seamless. Okay, now this is a discontinuous spectrum. This discontinuous spectrum, you can say this is a line spectrum. Line spectrum में क्या मिलेगा आपको? Sharp distinct line मिलेगा, a line मिलेगा. This is called discrete line spectrum, and this is given by atoms, and this is called atomic line spectrum. While you can see the band spectrum, you can see the wavelengths, cluster of wavelengths appear like a band. This is produced by molecules. This is used to check the behavior of the molecules. We are not going to study this band spectrum, rather we are going to study the line spectrum. Geeta? Yeah, Geeta Madhuri, it's a serious question and it is an important question here. I don't know, I don't have any favorite. Geeta Madhuri, your question. You see the rainbow during a rain time, and that is nothing but Vibgyor. So Vibgyor rainbow is same. But when you see the rainbow, you can't see all violet, indigo, blue, green, yellow, orange, red because of the climatic things. Some of the wavelengths are going to be missed. So you cannot reach all the wavelengths when you visualize it. So technically rainbow and Vibgyor are same. Geeta Madhuri, you understand your question? Right. So please use this short box to ask academic related, content related and concept related or anything examination related questions. So not spamming type questions. I really request my students to maintain the chart decorum. Okay. Now let us talk about emission and absorption spectra. So उसमें emission क्या होगा, absorption क्या होगा? So this is the nucleus. Atom का structure ऐसे होगा. So electron revolve around the nucleus in various types of shells. So अगर मान लो अगर electron higher energy shell से lower energy shell तक पहुंच रहे तो, okay, if the electron is jumping from higher shell to lower shell, it is going to lose energy, emit energy in the form of radiation or light. So this is called de-excitation process. Higher shell to lower shell is, and Geeta Madhuri, your question is valid. You need not have to say sorry. Okay, you always ask a question related to the context. So you don't have to worry. And this is called emission spectrum. And you can see the reverse when the electron is jumping from lower shell to higher end shell. So it need energy. When it need energy, it has to absorb radiation. So that this is called absorption, while it is called emission. जब लाइट एमिट करते हैं ना, emission spectrum मिलेगा. Okay, and vice versa. No, don't feel like that. Today new fundamental particle is going to be discovered which can bring big change in the physics chemistry. Is called muon. So particle physics is completely different and the structure of atom is completely different. In this particle physics you have bosons, muons, fermions and all. So structure of atom is not that. Structure of atom is how the electrons are arranged around the nucleus. And you are talking about the particle physics. and the fundamental architecture of the nucleus. That is different and this is different. Okay. Yes, let us be all toppers here, my dear children. So let us explore the things, let us interact. This is a live interactive session, my dear students. So you can interact with the senior faculty like me, and you can explore so many things, learn good things, and it is a competitive world where we have to prove ourselves where we stand. Jo jeeta wahi sikandar hai. Okay, so chilling is different and doing work is different. So emission and absorption spectra, whenever electron jumps from the higher shell to lower shell, it lose energy. So that lose energy means energy is emitted in the form of radiation. So that gives the emission spectrum. 30 plus marks in IOQM that can get Sri Chaitanya star badge. Okay, so Sri Chaitanya Academy is going to take care of your question. Okay, connect with any local branch that you have. Okay, talking about absorption and emission spectra, you can see when let us see here, hydrogen gas is here, and by putting a lot of electronic voltage over here, and you're going to dissociate this, and the electrons in this hydrogen atom is excited, and while it is de-exciting, it emits the radiation, and this radiation is passed through the prism and is going to get a spectrum like this. This is called emission spectrum or emission line spectrum of hydrogen. We are going to study that. Okay, and here when absorption spectrum is seen, when this light is passed through a cold gas, so this gas is going to absorb some of the wavelengths, and the rest of the wavelengths is passed through the prism, so that the absorbed wavelength is missing in this spectrum. That is called as the absorption spectrum. Okay, you can crack it, all the best. Sir, anyone NEET dropper who secured 520 plus in 2025, अरे 650 plus भी मिला. Who is that A2? In the YouTube channel, in our own batches in the Infinity Learn. So NEET batches are there where we got it. Okay, so talking about here line spectrum of hydrogen. So this is what is a de-excitation series, that is line spectrum of lines that we are going to see like this. So what exactly is happening? For your convenience sake, I just want to show you the hydrogen atom like this. Okay, hydrogen atom shells are seen to be spherical or circular. Okay, please don't make this chart, maintain the chart diagram, my dear children. Okay, is it possible in 5 months or 10 days? That's a different matter. Okay, focus here. For our convenience sake, instead of writing these circulars, I just want to make these parallel lines. So electron is present in n is equal to 1, shell number 1, shell number 2, shell number 3, shell number 4, up to infinite shells. है ना बच्चों? अरे बेटा, please focus here. Please focus here. When the electron is jumping from higher energy state to ground state, this is n is equal to 1 is called ground state. It is going to lose energy in the form of radiation, and this radiation is going to give an exposure on the photographic plate that is absorbed by Lyman, and this is called Lyman series. And the electron is jumping from higher shell to n is equal to 2, it is going to release the energy in the form of radiation, and this is going to produce a spectrum that is absorbed by Balmer. So this is called Balmer series. Yeah, please anyone don't disturb the class. If anyone has object related questions, please, related topics, please ask at the end of the class. Thank you very much, Geeta Madhuri. If the electron is jumping from higher energy shell to n is equal to 3, that is going to form a spectrum. Okay, that is given by Passion. So that scientist name is given to the spectral. So this is called Passion series and bracket series. and it is going to give a fund series. It is going to give fund series. Okay. Now you can see here, this is your hydrogen spectrum. Got it? And let us see, Bohr used this, today's topic of interest is Bohr's theory. Bohr used this data and re-explained the same, and it is experimentally found true. Okay, Phantom, I said no spamming in the chat. Please focus on the academic content. Okay, so when electron is coming from higher shell to lower shell, it is going to form a spectral line, and the spectral line is given by a name by the scientist of the discovery. And here, when you see, Balmer showed in 1885 on the basis of experimental observation that if a spectral line is expressed in terms of wave number, that wave number is a reciprocal of the wavelength. Yeah. And this wavelength is given by Bn square upon n square minus 4. So, this 4 comes like this, n value is second shell. That is the reason why n2 value is coming to be 4. Okay, 2, and the 2 square is equal to 4. Later, Reds and Rydberg showed this experimental data they given to calculate the wavelength. This is the wavelength, this is the light na, this is the light na. This light has a wavelength. That light wavelength is calculated by using this Rydberg equation, and that is given as, you can say, that is given as, yeah, we have to keep the formula in the mind, right? That is given as 1 by lambda is equal to nu bar is equal to Rg square of 1 by n1 square minus 1 by n2 square. Okay, so this is called Rydberg equation. What this lambda says to you, lambda is a wavelength, lambda is a wavelength, and nu bar is a wave number, and z is the atomic number, and r is equal to Rydberg constant. I'll give you the constant value, hold on, I'll give you the constant. Yeah, you have to keep the formula in the mind. N1 is to which shell the electron is jumping. So, here it is N1 value, understand? Here it is N1 value, right? Now, N2 value is going to be from which shell an electron is coming. Okay, from which shell an electron is coming. What is R value? Yes, my dear children. Okay, sorry, there is some technical lag over here, that's the reason why. So, what is the N1 value here? N1 value is to which shell an electron is coming, N2 is from which shell an electron is coming. Yeah. So, this is the Rydberg constant, it is a very important, and this value is going to be 109,677.8 centimeter inverse. How we can memorize this value and how you can put to calculate this big equation? So, no worries, you can use 1.1 into 10 raised 5 centimeter inverse, and still we have, yeah, what you N1 and N2. N1 is to which shell an electron is coming, N2 is from which shell an electron is coming. And you can say 1 by R is equal to 912 angstrom units. Okay, 912 angstrom units. So, this is the one, and this is a super awesome trick. You can calculate these spectral lines, and also you can see the Rydberg constant values can be taken from these E is equal to Hc by lambda. So, Hc by lambda is equal to 2.18 into 10 power minus 18 of 1 by N1 square minus 1 by N2 square. You take this Hc over here, you are going to get 1 by lambda. If you put H value and C value, what is the H value? Angstrom units, Karim. Hi Karim. So, H is equal to 6.626 into 10 raised minus 34 joule second, and C value is equal to 3 into 10 to the power of 8 meters per second. So, if you put these two constant value over there, you are going to get 109,677.8. So, I already given, and 1 by lambda is equal to 912 angstrom units is going to be the trick for this. Understand? That's good. And what about the spectra of other elements? If you use the hydrogen, this is the spectra. If you use the hydrogen, if you don't use hydrogen, any single electron species, you can say Z has to be included, Z square has to be included. Z is the atomic number, right? So, it could be anything. Or N1 value is to which shell an electron is coming, and N2 is from which shell an electron is coming. And let us see the detailed version of the hydrogen spectrum over here. And let us talk about the Lyman series, and it is the first spectral line that is seen in the hydrogen, but during the discovery chronological order, the hydrogen spectrum, Bohr series is the first is discovered because it is in the visible region, right? And from the ultraviolet region, it is found in the ultraviolet region, it is value, N1 value is equal to 1, N2 value is going to be 2, 3, 4, so on. And 1 by lambda is equal to R of 1 by 1 square minus 1 by N2 square, where N2 is always greater than 1 over here. And wavelength of the marginal line is going to be N1 square upon Rydberg constant. And for the Lyman series, if for all series, for the Lyman lambda is equal to 1 by R. 1 by R, as you said Karim, it is 912 angstrom units. So, 1 by lambda 1 by R is equal to 912 angstrom units, okay. And talking about the Lyman series, and the first Lyman series is also called as wavelength with the maximum value. So, it is what is called as alpha line, and this is what is called as a beta line, and this is what is called as last line, series limit. This is what is called as a series limit. When it is a series limit, the electron is coming from this infinity to n is equal to 1. So, it has a highest energy, lowest wavelength, lambda minimum, and E is equal to Hc by lambda. E is equal to Hc by lambda. So, E is inversely proportional to wavelength, understand? And it is going to be the minimum energy, and it is going to be the lambda max. So, in the question it may be given as a lambda max, you have to take 2 to 1 into the consideration. My dear children, it is very important, and you are going to have the question like this. And also you can see Lemon series, the longest line is going to be lambda longest or lambda maximum. So that is going to be 12400 delta E minimum, and the shortest line is going to be wavelength minimum, and energy is maximum 12400 energy upon energy maximum. That is very important point you need to know. And also see, first spectral line is going to be the longest wavelength, and the last spectral line is going to be the shortest wavelength. Okay. And also see, it is for the Bohr series as well, you have to follow the same algorithm. And maximum number of lines and maximum number of different types of photons in the case of a large sample, it is given as maximum number of spectral lines. Maximum number of spectral lines. Is going to be N2 minus N1, N2 minus N1 plus 1 and by 2. This is an empirical formula, can give you the finding maximum number of spectral lines, Karim, where N1 is coming to the lower energy shell, where N2 is coming to the higher energy shell. He observed, Bohr has taken these conditions and taken the various possibilities of the spectral line formation. And you can see, when the electron is coming from n is equal to 4 to n is equal to 1, you can see how many spectral lines can be formed. 4 to 3, one possibility is there. 4 to 2 and 3 to 2, 4 to 1, 3 to 1, 2 to 1, total 1, 2, 3, 4, 5, 6. 6 spectral lines can be formed. Each jump is going to be each photon out. So each photon is going to give rise to one possible spectral line. So this is a number from 4 to 1. It could be from any number to any number. You use maximum number of spectral lines is equal to N2 minus N1 and N2 minus N1 plus 1 by 2. So here 4 minus 1, here 4 minus 1 plus 1 by 2. So that is going to be 4 into 3 by 2 is going to be 6 spectral line. You got it? Clear? So you can either use the formula or you can use this manual way. But if it is given how many spectral lines are formed in the visible region, we have to go with the only manual method only. So my dear children, if it is a 5 to 1, the same way you can see the n number of jumps and you can calculate it. And the maximum number of spectral lines, I said n higher minus 2 lower plus 1 by 2. And we did this. And 5 to 4, 4 to 3, 3 to 2 and 2 to 1. Like that various possibilities are there. I just want to show you the various lines here. You have the Lyman series, Bohr series and the Passion series and the Bracket series and the Fund series. P silent enough. Let us talk about these are the spectral lines and you will be talking about this is a series and you have n1 value, you have n2 value, you have the region. You need to know this. When you see here, for Lyman series, you can see n1 is always 1. When the electron is coming to n1 is equal to 1, the electron can come from the 2, 3, 4 and it is going to be like this. And it is formed in the ultraviolet region. When the Bohr series n is equal to 2, electron is jumping to n is equal to 2 from the higher shell. So that it can come from 3, 2, 3, 4, 5, 4, 5 and so on. Passion series 3 and it is 4, 5, 6 so on. And Bracket series 4, 5, 6, 7 so on. And Fund series 5 and 6, 7, 8 so on. And it is going to be formed, Bohr series is formed in the visible region and it is going to be near infrared region, and it is going to form at a middle infrared region, and it is going to form far infrared region. Okay. So, to calculate the spectral lines of the wavelength of the spectral line, I just want to put you 1 by lambda is equal to r z square of 1 by n1 square minus 1 by n2 square. If you have any question from the structure of atom in the NEET examination, either Bohr's atomic theory, hydrogen spectrum and quantum numbers, these are the three major areas you can see a probable part of the questionnaire. Okay, Karim? Yeah, Humphrey series is there, but we don't see that Humphrey series. It is up to fund series, Kafia beta. Okay, Z is equal to atomic number. Anisha? And R value is equal to Rydberg constant. Rydberg constant, okay. This Rydberg constant is 10967.7.8 centimeter inverse, or 1 by R is equal to 912 angstrom units. So, this is maximum enough, right beta? Agar any doubt, you just ask us. Anisha and Karim, come on. Geeta Madhuri. Yes, let us follow the next part of this. And moving ahead, Bohr's atomic theory. Bohr has taken the initiative to give the actual theory of how atom is seen. Let us say the major defect in the Rutherford model. Major defect in the Rutherford model. This is the nucleus and this is the electron. It is said to be revolve around the nucleus. You see, it is said to be revolve around the nucleus like this. Now it is fine. Atomic structure is well defined here, no doubt about that. And he faced a question by Maxwell and Boltzmann developing electrodynamics during that era. So what they asked, when this is an electron which is a charged particle, when it is moving, it has to lose energy. When it is losing energy, it should lose energy continuously so that it is going to be attracted by the nucleus. So it should take a spiral path and it should fall into the nucleus. If that is the case, atom should collapse because electron and the nucleus, it has to be neutralized. Then what about the stability of the atom? This is the question asked by Maxwell and Boltzmann. Rutherford has no answer in that, right? So immediately Bohr did his work. He wanted to say, electron is there. This is the nucleus. Electron is there. He said it is a perfect circle and he said its energy is constant and he proved it. And he proved the radius of here and it is also constant. If you say the radius of like this, any point of instant, the radius is not constant. Here radius is constant. He calculated the radius, he calculated the energy and he said energy is constant and radius is constant by taking the angular momentum into quantization values. So he explained from the Bohr's atomic theory and he proved it is so. And he is such a smart scientist and theoretical physicist, he did it well. And let us see the details of the Bohr's atomic model. So when you see the Bohr, the atom, the electron is going to revolve around the nucleus in a confined shells, and this is what is called as the fast Bohr's model. Electron is going to revolve around the nucleus in a well-defined circular path, and these circular paths are called orbits. Okay, and let us see the details about this. And when the electron is revolving around infinite number of shells, and these shells are given as n is equal to 1, n is equal to 2, n is equal to 3, 4, or is also said K shell, L shell, M shell and N shell. okay, and these shells, and electron should have a permission to revolve in that shell only, and electron cannot move here. Electron has to move either here or here. It cannot take a revolution in between these two. It has a fixed shells, right? Clear? And that is what when an electron revolving around the nucleus, its energy is also constant. Okay, its energy is also constant. Okay, when electron jumps from the higher shell to lower shell, it loses energy. It is energy is lower shell to higher shell, it is going to gain the energy. I mean to say, either it can have n is equal to value, it is calculated to be minus 13.6 electron volt. If it is equal n is equal to 2, its value is going to be minus 13.6 upon 2 square. Okay, and electron should have the permission to revolve here or permission to revolve here. Okay, so as the greater the distance from the nucleus, the distance between the consecutive shells is going to be decreased, and you can see limitations, and electron revolves only in those orbits whose angular momentum is equal to n h by 2 pi. N is the shell number and its value is going to be 1, 2, 3, 4 and so on, and its value should be multiple of h by 2 pi. So, if it is said to be MVR is equal to NH by 2 pi, if the electron is revolved in the K shell, okay, its angular momentum is going to be n is equal to 1 h by 2 pi. If L is equal to 2, so L shell, so MVR is equal to h by pi, and M shell, the electron is revolving, MVR is equal to 3h by 2 pi. So, you can see the angular momentum for the shell to shell is a variable, so that atom should have no conflict in revolution in one shell to another shell. So, atom is said to be stable. That is very, very, very important. This is what is called as quantization of angular momentum. MVR is equal to angular momentum, N is the shell number, H is the Planck's constant 6.626 into 10 to the power minus 34 and 2 pi. And you can see one more point, if the electron jumps from lower shell to higher shell, it should absorb energy. It should absorb energy. And that energy gap, when electron is jumping from n is equal to 2 to n is equal to 3, the difference between these energies is said to be E3 minus E2. So, delta E is equal to hc by lambda. I just want to show you the energy. If the electron is jumping from higher energy to lower energy, it is going to lose energy, so that is going to emit energy. That is given as E2 minus E2. So, that values is generic, it is given as delta E is equal to E2 minus E1 is equal to hc by lambda, and the wavelength of this jump is calculated by using the data from the hydrogen spectrum. Hope you understand. That is very, very important, and among all points, every point explained by Bohr is nothing but Rutherford model only, but he got only one point to be added, that is equal to angular momentum is quantized. Okay, that is MVR is equal to NH by 2 pi. And you can say, so the model is valid only for single electron species like hydrogen, helium plus and lithium 2 plus and beryllium 3 plus. Karim, if you have any doubt, you can please ask us. If you have any doubt, you can ask us. Yes. Now, so in an atom, electrons and the nucleus are held together by strong electrostatic force of interaction. So, there is a attractive force towards this nucleus, that is called centripetal force. Opposite to that, centrifugal force is there. Centripetal force is going to be centrifugal force. They are opposite together. And force of electrostatic charges is equal to centripetal force, kz square by r square is given as. Okay, that is called as kz e square by r square. Okay, and you can say kz e square by mr, it is from equating the both forms, mv square by r is equal to kz e square by r square. This is the centripetal force, force of attractions from the Coulomb's law, and it is the centrifugal force. And on rearranging v square is equal to kz e square by mr, and on doing so we can take the radius from here. You can say according to Bohr's postulates, mvr is equal to nh by 2 pi and is equal to v is equal to nh by 2 pi mr, and this is the formula to calculate this velocity of the electron revolving in a particular shell. And also you can say calculation of Bohr's on deriving, so you are going to get the radius of the electron shell is going to be 0.529 into n square by z angstrom units. Okay, or you can say into the centimeters, 1 angstrom unit is equal to 10 power minus 8 centimeters. Okay, so this is a very important. I just want to say radius is directly proportional to n square, radius is inversely proportional to z. Z is the atomic number, right my dear children? Right. Okay, and also Bohr's radius of second orbit of beryllium 3 plus is equal to that. You can see the NEET examination questions will be like that. I want you to solve this question and let us know what is the best you can do it. So, will you solve and you want me to solve? Karim, Geeta Madhuri, Anisha, all students who are on live, please come on. How to solve this? You want me to solve this? So, typical NEET examination question. It's a typical NEET examination question. Right here, we know the Bohr's radius for nth orbit is going to be 0.529. Okay, you can approximate it 0.53 into n square by z, where z is the atomic number. So, it is asked for the beryllium 3 plus. इसमें कितना हो सकता है? It is going to be Bohr's beryllium 3 radius of this is equal to 0.529 into 2 square by 4 is equal to 0.53. So, this value you have to correlate with this 4. So, fourth orbit of hydrogen is going to be 0.53 into 4 square. Hydrogen is going to be z is equal to 1 and it is going to be 0.53 into 16. So, this is not the answer. This is not the answer. Okay, and let's see Bohr's radius of second orbit of helium plus is going to be 0.53 into 2. So, this is not the answer. Third orbit of the lithium 2 plus. Third orbit of the lithium 2 plus is going to be 0.53 into 3. So, this is not your answer, bacho. And it is going to be Bohr's radius of first orbit is going to be in calculated 0.53 into 1 square by 1 is going to be 0.53 angstrom units. So, it is going to be the answer for this question. So, my answer for this question is going to be option D. So, this is the methodology you have to adapt to calculate questions based on the given NEET pattern. Okay, will you do one more question, my dear students? If you have any doubts, please let us know. If you have any doubts, please let us know. Okay, now if the radius of second Bohr orbit of helium plus ion is 105.8, what is the radius of the third Bohr orbit of the lithium 2 plus? This can be easily resolved. Atomic, according to Bohr's model, we know that radius is inversely proportional to z and directly proportional to n square. And by taking this, n1 value is going to be 3, z1 value is equal to 3, and N2 value is equal to 2 and Z2 value is going to 2. Helium na? And lithium na? Lithium 3, helium 2. So that take the ratio between these two and I am going to get 158.7 picometers. So my answer is going to be option B. Got it? Any doubt? Hi Nandu, how are you? I am fine, Nandu. Right. Now let us talk about calculation of velocity of an electron in a Bohr's orbit. This is also very important. We know that the electron revolving around the nucleus has some value of the velocity, and that velocity value can be calculated from the mvr is equal to nh by 2 pi. So mvr is equal to nh by 2 pi, v is equal to nh by 2 pi mr, and we have the radius expression. Put it there and you are going to get r value, you are going to get velocity value is going to be 2.18 into 10 raised to 6 into z by n meters per second. So for your clarity, velocity of the n value is going to be 2.18 into 10 raised to 6 into z by n meters per second, okay. So I wanted to say, as the electron is moving away from the nucleus, it becomes slow. So when it is close to the nucleus, it moves fast, and it is moving away from the nucleus, it is going to be slow, right? And also you can see the time period of the revolution of electron in its orbit is equal to time period is equal to circumference by velocity. We know the 2 pi r upon velocity, and also the frequency, the number of revolutions in a second is called velocity, that is inverse of the time is going to be velocity by 2 pi r, and r is the radius and the v is the velocity. So these are all the formulas that you need to have on the fingertips, and you can do the best. So dear students, let us talk about the energy of the electron. Every electron, when the electron revolving around the nucleus, it should have the energy, and this energy value is always constant. And this energy value is calculated by Niels Bohr from theory. The kinetic energy is equal to half mv square, and the centripetal force is equal to Coulombic force is therefore mv square by r is equal to kZe square by r square. From there we can calculate it. mv square by r is equal to kZe square, okay. From there you can say put the r value there, and hence Ke is equal to kZe square by r. This formula is very important, and also you can say calculation, substituting this value r in this equation, you are going to get total energy is equal to kinetic energy plus potential energy. This is called kinetic energy, and this is a potential energy. You see, kinetic energy is a positive quantity, and potential energy is a negative quantity. You can see the magnitude. So potential energy is double as compared to the kinetic energy, and total energy is equal to the kinetic energy, and the magnitude is same, but it is a negative quantity. Mind it. Based on this, you can say various questions you can do in the chemistry as well as you can do in the physics as well, okay. Now from here total energy is equal to minus kZe square by 2r, and it is putting in the r value, you are going to get total energy as minus 13.6 into z square by r square electron volt per atom, and energy of the electron is also 2.18 into 10 raised minus 18 into z square by n square joule per atom, and also it is going to be erg per atom, kilojoules per atom, kilocalorie per atom and kilojoules per atom. I just want to say always Nandu and total energy and kinetic energy both are same magnitude, but total energy is a negative quantity and kinetic energy is a positive quantity, and is going to be potential energy by 2, and by using this formula you can crack multiple type of questions. Okay, that is very important. Now, calculation of energy or ratio of third orbital lithium ion and second orbit of beryllium 3 plus ion can be calculated. Okay, energy differences. Let us calculate the energy differences between the shells. And when electron is jumping from lower energy to higher energy shell, it should absorb energy. है ना? Similarly, when the electron is coming to the higher energy shell to the lower energy shell, it should lose the energy, and that energy is given delta E is equal to energy of the higher shell minus energy of the lower shell, right? That is going to be minus 13.6 into Z square by N higher shell, H stands for higher shell, minus 13.6 into Z square by N lower shell. And 13.6 common nikal, you are going to get minus 13.6 into Z square of 1 by higher shell square minus 1 by lower shell square, and negative is taken and the fraction is going to be reversed and it is going to be this. And also you can see this, the same value, this is generously used to solve so many NCERT questions. Delta E is equal to 2.18 into 10 power minus 18 into Z square of 1 by N1 square minus 1 by N2 square, and this is in joules. It is in joules. Understand? Clear? That's great. And energy differences you can see by using electron volt per atom, you can use joule per atom, and these are going to be generously used in calculating the things. 1 electron volt is equal to 1.6 into 10 raised minus 19 joules. That is also very important. Nandu, fine, you hope you understand. Karim? Okay, this is not a radio session, this is the live interactive session. You can discuss with us and we can talk to each other, right? Come on, dear children, let us talk about energy differences. The same way, yeah, ground state. The ground state. If this is a nucleus, this is N is equal to 1, and this is N is equal to 2, and this is N is equal to 3. So, this is called ground state, and this is called first excited state. This is what is called second excited state. Hope you understand. Clear? And ionization energy. The energy required, minimum energy required to move an electron from ground state to the infinity state. Why? Because in the ground state, that is E1, and it is going to be E2 is equal to 0. If you take the electron from the infinite distance from the nucleus, its energy is going to be 0. That is given as ionization energy, that is equal to plus 13.6 into Z square इलेक्ट्रॉन वोल्ट पर एटम. सो इलेक्ट्रॉन का जितना एनर्जी है एटम में ये नेगेटिव होता है. इफ यू गिव उतना एनर्जी, if you have the same amount of energy, its energy value is going to be 0. So ionization energy is going to be plus 13.6 into Z square. So for hydrogen or anything, otherwise you can also say ionization energy plus 13 point, this is going to be ionization energy of the hydrogen into G square. It could be anything, right? Now, what is the meaning of ionization potential? 13.6 into g square electron volts. Z is the atomic number of the species. And excited state. What is the meaning of an excited state? Other than ground state, above initial is called excited state. Energy state of the atom other than the ground state is called excited state. If you are removing electron from the atom is called ionization energy. If you are removing the electron from any one of the excited state is called separation energy. So that is given as separate first, so n is equal to 2 first excited state, n is equal to 3 second excited state. It goes like this, n is equal to 4 third excited state. So, n is equal to n1 plus 1, that is nth excited state, right. Now, let us see separation energy. Ionization energy we already discussed. Minimum energy required to move an electron from the ground state to n is equal to infinity. And single electron system. This is ionization energy. Remove the electron from ground state. And separation energy. Remove electron from any excited state. So, उस दोनों में क्या फर्क पड़ता है? Ionization energy is equal to plus 13.6 into z square, है ना? So, this is what is called separation energy, SE. So, separation energy is equal to the same only 13.6 by z square by n square electron volt. Okay. So, you can use these formulas and you can do the best. Got it, my dear children? And also single electron system. Single electron system. It is going to give the quantum approach. Okay. In this scenario, a single electron system means these hydrogens and hydrogen-like species is called single electron system. Bohr's atomic theory is only applicable for single electron system, like hydrogen, like helium plus, like lithium 2 plus, like beryllium 3 plus. Bohr's atomic theory cannot explain the existence and the structure of multi-electron system, but it is explained only single electron system. Quantum means defined quantity. It could be the energy packet, it could be the defined path of the electron. Quantum means defined. Something has a definite value is called quantum. Fine. Whenever you ask something, I am ready to help you. Now, Bohr's atomic theory is only applicable for hydrogen and hydrogen-like species. And Bohr's atomic theory explanation is only 2-dimension. Bohr's theory failed to explain the 3D picture of the atom. So, according to Bohr, atomic structure is flat. And also, Bohr cannot explain the fine spectrum of hydrogen. So, if you see the Lyman series, Balmer series, bracket series, he explained why Lyman is formed, how Balmer is formed, how Paschen bracket fund is formed. When you see each line under microscope, these lines got some sublines in it. He cannot explain that. That is called fine spectrum of hydrogen. And also Bohr cannot explain the Zeeman effect and Stark effect. What is Zeeman effect? Splitting of spectral lines in the strong external magnetic field is called Zeeman effect, and the Stark effect. The splitting of spectral lines under strong electric field is called Stark effect. So, these two cannot be explained by Rutherford. Niels Bohr. So later it has to be explained on the basis of Sommerfeld and Uhlenbeck and the other scientists. By magnetic quantum number is also explaining Zeeman effect and the Stark effect. And let us see here excitation energy, that's what we already discussed. Binding and separation energy we discussed. Okay. Yeah, this is a super awesome thing. As you know, energy of the electron for the hydrogen is going to be minus 13.6 by n square electron volt. So, if the electron is n is equal to 1, its value is equal to minus 13.6. Answer key is out. आने वाला है बेटा, जय श्री राम, and minus 13.6 electron volt, and it is if the electron is n is equal to 2, that is going to be minus 13.6 by 2 square, that is minus 3.4. If the electron is revolving in n is equal to 3, it is going to be minus 13.6 upon 3 square, that is minus 1.51. And electron is revolving n is equal to 4, that is going to be minus 13.6 by 4 square minus 0.85. So, like this you see the energy value minus 13.6 to minus 3.4, the value is increased, energy value is increased, energy value is increased when the electron reaches to infinite distance from the nucleus. It is going to be 0 electron volt, right? So, I want to see here 13.6 electron is here 13.6 and electron is here, that is a minus 3.4. ये दोनों का अंतर आता है 10.2. I want to say this is the important parameter. Delta E is equal to E2 minus E1. So, wanted to say everybody look at here. If an electron want to jump from here to here, it should gain 10.2 electron volt, mind it. If an electron want to jump from here to here, it should lose 10.2 electron volt. That precise calculation is given by Niels Bohr. Are you getting or not? Clear? And similarly, if the electron want to jump from here to n is equal to 3, it is going to be 12.09 volt, it has to gain. If the electron want to lose from here to here, it has to lose 12.09. And also you have one important thing, total energy is equal to minus kinetic energy is equal to potential energy by 2. When the electron is revolving in this place, its total energy is going to be minus 13.6. Its kinetic energy is going to be plus 13.6. Its potential energy is going to be minus 13.6 into 2 electron volt. Mind it, you understand? Clear? And if the electron is revolving around the nucleus in the shell number 2, total energy is equal to minus 3.4 electron volt. Kinetic energy is going to be plus 3.4 electron volt. And the potential energy is going to be minus 3.4 into 2 electron volt. Hope you understand. So, when the electron is moved from lower shell to higher shell, its total energy is increased, kinetic energy is decreased, and the potential energy is increased. And when the electron is jumped from higher shell to lower shell, its total energy is decreased, and kinetic energy is increased, and the potential energy is also decreased. And this is a noteworthy point that you need to know, and this is a super awesome formula where you are going to see the questions, and by using this particular slide you can crack the questions from the NEET examination, from even from the physics as well as in chemistry. And hope you just see this hydrogen spectrum and the Bohr's atomic theory in today's class, and hope you love this class, my dear students, and we'll meet with more stuff about the paper discussions and the paper keys out, result analysis sessions and all. So stay tuned, my dear children, and please like this session and share with your friend and subscribe to Infinity and NEET YouTube channel. Thank you very much. Signing, Suresh, Faculty of Chemistry from Infinity Land. Thank you.